IGCSE Chemistry, Paper 2, October, November 2021. So we want to quickly go through these questions as fast as we can, and we hope that you will be of utmost, you give your listening ear. Let's go through the questions together. An experiment is set up as shown. So you can see this experiment, you can see a cotton wool soaked in ammonia from this end. There's a cork here that covers this tube. There's also a cork on this side that covers this tube. So whatever gas is here doesn't escape. Now this cotton wool on the right side is soaked with hydrochloric acid. Okay, after several minutes, a white ring of ammonium chloride, NH4Cl, NH4, this ammonium. Ammonia is NH3. Ammonium chloride is NH4Cl. Okay, so a ring of ammonium chloride appears as shown. So you see the ring. Can you see the ring of ammonium chloride? Appears here. So you can see it's like the one. This is the wood that's soaked with ammonia, and this is the wood that's soaked with hydrochloric acid. So it appears that the ammonia one traveled faster. You see, it went all a longer journey. See, from here to here was a longer journey. Okay, compared to what is obtained on the other side, compared to what we see the journey from the hydrochloric acid from here to here. Okay, so you can see that the ammonia here travel a longer distance than the one here. Now, which statements explain the observation after several minutes? Which statement explain the observation, what you've just seen, the ammonium chloride that is formed, chloride that is formed somewhere here closer to the to hydrochloric acid? Which one explains? Now, you say ammonia gas diffuses faster than hydrogen chloride gas because its molecule have a lower molecular mass. That's true, right? See, it diffuses very faster. It travels a longer distance, the ammonia gas. You know the ammonia gas is here because this cotton wool is soaked in ammonia, and while the other cotton wool is soaked in hydrochloric acid or hydrogen chloride gas. So you can see, it's safe to say that the ammonia gas diffuses faster than the hydrogen chloride gas because its molecule have a lower molecular mass. Of course, if you have a bigger mass, you cannot diffuse faster. Its molecule has a lower, this word is very important because its molecule has a lower molecular mass. So A looks correct, but we have to go through all the options. You don't just say, oh, A, and you pick A. Ammonia diffuse faster than hydrogen chloride gas because its molecule have a higher molecular mass. No. If you have a higher mass, you will not be able to move faster. So B cannot be correct. It actually diffuses faster, but because the reason they gave, they say it has a higher mass. It couldn't be that option. The third option, C, it says ammonia gas diffuses slower. It doesn't diffuse slower. It has to travel a longer distance, so it cannot be the answer. And the fourth option, ammonia gas diffuses slower. So this C and D already out. C and D both out. You know why? Why is it out? Why is C and D out? For the fact that it's saying that ammonia gas diffuses slower. It's not true. It was ammonia that diffused faster. So these two options are already like they killed themselves. The right answer is between A and B, and we go for option. Go for option A. Okay, that's for question 1. Now let's move to question 2. Question 2 says a student puts exactly 25. Question 2 says a student puts exactly 25 centimeter cube of dilute hydrochloric acid into a conical flask. 25 centimeter cube of dilute hydrochloric acid into a conical flask. And the student added 2.5 grams of solid sodium carbonate. You must know how to write this is the chemical formula. Sodium carbonate. 2.5 of sodium carbonate. Okay, the student added 2.5 gram, that's the mass, 2.5 gram of sodium, and measured the change in temperature of the mixture. So first of all, a student put exactly 25 centimeter cube. So this is a volume. This is volume. You know the instrument for measuring volume. So it says student put exactly 25 centimeter cube of dilute hydrochloric acid into a conical flask. We put the acid in a conical flask, and then we pour the base in titration in chemistry. You pour the base on the burette, and you start dropping into the acid until you wait for a color change. So the student added 2.5 centimeter cube of sodium carbonate and measured the change in temperature of the mixture. Now, which apparatus does the student need to use? Which apparatus is he going to use to measure all of this? Remember, you've heard of mass, so you have to know, you heard of volume. We have volume, we have temperature, we hear mass, right? So you think of which instrument is used for measuring mass, you heard of volume, you think of which instrument the student will use for measuring volume, okay? And then you've heard of temperature. I think he measured the change in temperature of the mixture. So you heard temperature. You also think which instrument is used for measuring temperature. So if you can find this instrument for measuring these following parameters, and then I think you'll be good to go. Is it A, balance? Yes, you use balance for measuring mass. B, measuring cylinder for volume, thermometer for temperature. Could it be the most absolute for measuring the volume? In chemistry, is it measuring cylinder that is the most absolute for measuring this thing? No. B is balance for mass, pipette for volume, and stopwatch for time. There's no time, it's temperature. So B is absolutely wrong. B is absolutely wrong. C, you say a balance for mass, which is correct. Pipette for volume and thermometer for, I think C is correct. Burette for volume, pipette for volume. So you cannot have volume. So D is absolutely wrong. B and D are absolutely wrong. You're left with A and C to choose from. A and C are correct, but why we go with C, why we choose C, is because in chemistry, pipette and burette are better measuring devices for volume. They are better measuring device for volume. Volume of liquid, yes, we normally use a measuring cylinder. But when you talk here, you're talking about acid, you're talking about alkali, we use pipette and burette. Anytime they measure pipette or they measure burette, so it's always better for us to use anytime they measure acid, it's always better to use pipette or burette. Burette most basically for measuring the acid and pipette for the alkali. Okay, so that's for that. So C is the most absolute answer for this question. And then we go to question number 3. A student separates sugar from pieces of broken glass by dissolving the sugar in water and filtering off the broken glass. A student separates sugar. You want to separate sugar from pieces of broken glass. And this separation is easy, right? Because one is soluble in water, the other one is non-soluble in water. So by dissolving the sugar in water and filtering off the broken glass. So the broken glass and the sugar, you dissolve them in water and you pour them in a funnel through a filter paper. You get the residue. The broken glass will stay here, cannot pass through the filter paper. The sugar that dissolves in water will come down here as filtrate. So what is the filtrate? The filtrate is the sugar solution, right? Not just sugar, because it's dissolved in water. It's called sugar solution. So the filtrate is not broken glass. That is residue. Broken glass is a residue. Broken glass for sugar solution, no. Pure water, no. Well, you're not getting pure water because you dissolve sugar in water, so you're not going to get pure water. So the answer will be D, sugar solution. What do you mean by sugar solution? Sugar that has been dissolved in water is called sugar solution. Okay? Now let's move to the next question. Here we're going to do small mathematics. How many protons, neutrons, and electrons are there in the atom of isotope aluminium-13? Okay, now the atomic number, which is 13, is equal to the number of protons. So proton is 13. So here proton is 13. So proton is 13. Number of proton equal to number of electrons. So electron is also 13. Electron, you can just equal to E. Instead of writing electron again, equal to E. They're 13. Then how do you get the neutron? N. The neutron is the mass number, which is 27. Mass number minus the proton number or minus the atomic number to get the neutron. So 27 minus 13, I think we get 14, right? I think we get 14. 27 minus 13, that will give us 14. So the neutral will be 14. So if you are asked to identify this number, proto is 13, yes. So let's look at A. Proto is 13. Neutral is 13. This is wrong. Neutral, we've calculated, is not 13. So A is wrong. All of them are not 30, 30, 30. B, proto is 30. Neutral is 40. And this one is 30. Electron is 30. Yeah. B looks to be correct. But you have to check all this. Proto is not 40. And proto is not 40. So this and this are outrightly wrong. Outrightly wrong. So the correct answer is B. The correct answer is B. Proto is 13. Electron is 30. And neutron is 14. Okay, so that's for that question. Now let's go to question number 5. We have to try as much as we can to finish all the questions. Which description of brass is correct? Brass is an alloy. Remember this. Brass is an alloy of other metals. It's not a compound, it's not an element, it's not an element, it's an alloy. Okay, this question is pretty easy. We go to question number 6. Some properties of diamond are what? You know, diamond is very hard. Diamond is very hard, so it's a property of diamond, right? Every atom form four bond. No, this is graphite. Graphite is every carbon form bond with 4 other carbon. But diamond form, every carbon form bond with 3, not with 4. So this one is wrong for diamond. Okay? If you know diamond, how is everyone form a bond with 3 in the case of diamond. Okay? Every atom we form bond with 3 other atoms. Every atom we form bond with 3 other atoms in the case of diamond. So this one is wrong. It does not conduct electricity. Yes, diamond does not conduct electricity. It's hard. It does not conduct. Graphite conducts electricity. Diamond does not. So we look for 1 and 3. A, 1 only, 1 and 2, 1 and 3. So C is the correct answer, 1 and 3. Is that okay? Okay, sorry. I thought he said which properties are also shown by silicon oxide. I thought they were asking, okay, we have to check again if C is correct. Okay? Because they say which property are also shown by silicon oxide. Silicon oxide is hard. Silicon oxide form bond with 4 atoms. No, form bond with 3 atoms as well. And silicon oxide does not conduct electricity. Only graphite conducts electricity. So I think we are still correct. C is still correct. So luckily we are still correct. Now let's go to question 7. What does question 7 has to tell us? What does question 7 has for us? It says which statement describes the attractive forces between the molecules? Attractive forces between molecules. Which statement describes the attractive forces between molecules? Now there are strong covalent bonds which hold molecules together. The forces between molecules. Let's see the other options. They are strong ionic bond which holds molecules together. They are weak forces formed between covalently bonded molecules. Yeah, I think right. They are not strong forces. Which statement describes the attractive forces between molecules? Molecules don't have strong bonds, right? Yeah, they don't have. They're covalent bonding. They're not a strong bond. Okay, they are not ionic bond. They are weak forces formed between covalently bonded molecules. For example, carbon dioxide. Okay, molecule of carbon dioxide is between carbon and this is covalent bonding, and they are weak bond. Covalent bonds are regarded as weak bond, like methane. The bond between methane is between sulfur and hydrogen. Okay, this bonding, when you have one carbon bonded by 4 hydrogen from all directions, bonded by hydrogen, is called a weak covalent bonding. It's called a weak covalent bonding. Okay, so this is not a strong bond. Covalent bonds are not regarded as strong bonding. Okay, it's only ionic bonds are strong bonds. Okay, so we say option C seems to be more correct. We have option C say they are weak forces formed between covalently bonded molecules. So we go with C for this option. Now let's say which statement is described as a micromolecule. Ammonia is not a micromolecule. Graphite is a micromolecule, right? Iron is just an element, it's not a macromolecule. Macromolecule are giant molecule. Okay? Is ammonia a macromolecule? Graphite, iron, sodium chloride. Is sodium chloride a micromolecule? No. The answer is B. 8. The answer is B. Graphite. You know, macromolecule include the one we talked about, diamond. Diamond is a macromolecule. Diamond, graphite, and silicon 4 oxide, or silicon dioxide, silicon 4 oxide. Diamond, these are macromolecule. Okay, they form giant macromolecule. Diamond, graphite. Remember, graphite and diamond, they are allotropes of carbons. Remember that they are allotropes of carbon. That means types of carbon. Graphite and silicon 4 oxide. So I will just write Si silicon 4 oxide O2, SiO2. So these are macromolecule. Okay, any of this, if it's mentioned, becomes the answer. These are macromolecules. Is that okay? Now let's move to the next question. Question 9. Question 9. The equation for the reaction of sodium with water is shown. Sodium react with water, you get sodium hydroxide and hydrogen gas, right? When you dissolve sodium in water, you get sodium hydroxide, which is alkali, and hydrogen gas. Now, what is the volume of hydrogen gas measured at RTP? Produce, measure at RTP, the volume of hydrogen gas. Okay, remember the volume formula? You still remember the volume formula that has, there are two volume formula when you study mole. Okay, there are two volume formula we're going to look at. You say, what's the volume of the volume formula? What is the volume of hydrogen gas measured at RTP? Okay, produced when 80.4 gram of sodium react with excess water. First, you have to write the molar ratio. You have to write the molar ratio. So we have ratio 2 to ratio 2 to ratio 2 to ratio 2 to ratio 1. Okay, so first we calculate the mole, the one that is given to us. Now you say, what's the volume of hydrogen gas? Even though they're asking us for the volume of hydrogen gas, measured at RTP at room temperature and pressure, produced when 80.4 gram of sodium react with excess water. 80.4 gram of sodium, right? So we can calculate the mole of sodium. So mole of sodium is mass, mole for sodium. Sodium, mole of sodium is equal to the mass, which is 80.4 divided by the molar mass. What's the molar mass of sodium? 23. Sodium 23, right? I mean the molecular mass or molar mass. So 80 divided by 80.4 divided by 23. Quickly press your calculator. 0.8. Okay, so the mole here is 0.8. So we get 0.8. So since they asked us to find the mole of hydrogen gas, the volume of hydrogen gas, we need to get the mole of hydrogen gas. Okay, we need to get the mole. The mole we got just now, the 0.8, is for what? Is for sodium, right? It's for sodium. So ratio 2 gave 0.8. Ratio 1 will give what? Ratio 1 is half of ratio 2, right? Ratio 1 is half of ratio 2, right? So hydrogen is ratio 1. Since it's ratio 1, here will be 0.4. So the mole of hydrogen will be 0.4. The mole of hydrogen is 0.4. And volume is mole over 24, right? Or mole is volume over 24. Which of them? Volume is mole over 24 or what? Quickly. Volume is, you still remember or you forgot your formula for mole? Okay. Mole, number of mole equals to volume over 24 dm cube. Number of mole, so I write mole here. Number of mole is equals to the volume divided by 24 dm cube. Okay, 24 dm cube. However, if what we have is not in, we know how to convert for dm cube to centimeter cube. Okay, so since we know the mole of hydrogen, we can calculate the volume, right? We know the mole of hydrogen. The mole of hydrogen is 0.4. So hydrogen, why is the mole of hydrogen 0.4? The mole of hydrogen is 0.4 because the molar ratio is 1 compared to the mole of sodium, which has a molar ratio of 2. So you have to divide this by 2 to get the mole of hydrogen. Okay, so the mole of hydrogen is 0.4. So since you've calculated the mole of hydrogen to be 0.4 mole, the mole of hydrogen to be 0.4 mole, so to calculate the volume, you use this formula. Volume is mole times 24. So volume of hydrogen will be equal to the mole times 24. So mole times 24 dm cube. Times 24 dm cube. Okay, at room temperature and pressure. So the mole is 0.4, right? The mole of hydrogen is 0.4 mole times 24. So 0.4 times 24, what do we get? $9.6, right? So we get 9.6. So we get 9.6 decimeter cube. Remember, we are doing in decimeter cube. 9.6, that's the unit of volume, decimeter cube. 9.6 decimeter cube. So please, you should pause when you're watching this video and try to understand. How do we do it? First, we calculate the number of mole of sodium. Because why did you do the number of mole of sodium? Because they've given us, so the answer is A. Because they've given us the mass of sodium. And we know the molar mass of sodium. You can check that from the fourth, what do you call this, periodic table. You can check your periodic table and you get the molar mass of sodium. So you say 80 divided by the molar mass, which is 23, you get 0.8. 18.4 divided by 23, you get 0.8. That 0.8 you compare with their molar ratio. Okay, this is ratio 2 because there's 2 molecules. This is ratio 2 because there's 2 molecules of water. This is ratio 2 because there's 2 molecules of what? Sodium hydroxide. This is ratio 1 because there's 1 molecule. This 2 here is atom. We're not talking about number of atoms. We're talking about what is at the back here, is the molecule. There's 1 molecule of hydrogen gas, so you get this. So after you calculate the mole, you get 0.8, which is mass divided by mole of hydrogen. I think I did that here. The mass of hydrogen divided by molar mass of hydrogen gets 0.8. So 0.8, to get the mole of hydrogen, because this is for sodium, to get the mole of hydrogen, you will divide the mole of sodium by 2. Why? Because the molar ratio is 1. Why the molar ratio of this is 2? If this was 3, and you want to get 1, you divide by 3. Okay? So you get the molar ratio, or you can do extrapolation. You say 2 equal to 0.8, 1 will be equal to x. You cross multiply and you get the value. You get 0. You still get 0.4. So once you get 0.4, which is the mole of hydrogen, what you do next is to find the volume. You bring the volume formula that relates mole. Volume, this is not the only volume formula. There's another volume formula which says concentration equals to mole over volume. Concentration equals to mole over volume. But we are not using that one. We just need volume-mole relationship. So you say mole is volume divided by 24. So volume will now be mole times 24, which gives us 9.6 decimeter cube. Okay, so our answer for this calculation is A. Now we go to question number 10 quickly. We go to question number 10. This type of calculation question, they take a bit of your time, but you speed up your time with the ones that do not require calculations. Okay, you speed up your time with questions that do not require any calculation. Let's take a look at iron can be electroplated with zinc to make it resistant to corrosion. So meaning you can coat iron with zinc. Iron in presence of oxygen, presence of water, iron will start to rust. So if you don't want it to rust, one of the things you can do, you coat it with zinc using electrolysis. You can use the electrolysis, use zinc as the electrode to coat the iron, and so that iron will not rust. Okay? Which row about electroplating iron with zinc is correct? Now the positive electrode in the electrolysis process, the positive electrode and the negative electrode, which one should be iron? Okay, which one should be iron? We know if you are electroplating with zinc, must be zinc nitrate. Zinc nitrate. Zinc nitrate. NO3. Zinc nitrate. Zinc there's plus 2 here, right? Zinc iron is 2 iron. If it is 2 iron, then there will be 2 here. Okay, this is zinc nitrate. This must be used because if you are going to coat with zinc, you need zinc nitrate. So we will go for any option that has zinc nitrate. Okay, our answer will be we go for options that has zinc nitrate as the electrolyte. Now, what differs now is which one you use as the positive electrode. The positive electrode is the anode, and the negative is the cathode. So since you are going to coat iron, you should put it in the negative electrode. So iron should be in the negative electrode. Okay, should be in the negative electrode, and this positive electrode should be zinc. This positive electrode should be zinc. The iron that you're going to coat should be iron. This one you're going to coat, it should be iron. Okay, because this is negative, it goes to the negative terminal of the battery. This one accepts electrons. Okay, why this one give electron to this one? Gives electron. So the electrolyte is here, which is zinc nitrate. The zinc nitrate is here. Let's say the zinc nitrate is here. Okay, we can extend it here. The zinc nitrate is here, all the way here. Okay, so to save time, we just know that this one here will be iron, because this is the one you have to electroplate. Any one you are electroplating, you put on the negative, the cathode. The one you are using to electroplate it, you put it there on the positive electrode. So our answer goes with D. D is our answer. We move to the next question. Okay, to save time, because we spend too much time in that question. Let's see the next question, question number 11. Question 11. Now, chlorine reacts with ethane to produce chloroethane and hydrogen chloride. This is substitution reaction. Okay, chlorine will display, see, chlorine is a dye, is like this, Cl2. Chlorine is like this, Cl2. If you want to do the bonding, you do chlorine to chlorine single bond. If you are doing the bonding, it's chlorine to chlorine single bond. So what they are showing you, they are showing the bond, the structure. Okay, so it actually means Cl2. Okay, this Cl to Cl, it means Cl2. Okay, if they do for oxygen, O2, the bonding will be O to O double bond. Oxygen is double bond because it needs 2 electrons to complete its rule. Okay, the atmosphere. So it needs 2 electrons, so it's a double bond. Chlorine needs a single electron, so it's a single bond. Depending on the number of electrons you need to get from metal, it depends on the bonding you have here, whether it's going to be single, double, or triple bond. Okay, now what happens is that one atom, this atom, we drive this hydrogen, we replace this hydrogen. So you have chloroethane. This will become chloro now. Because of this, it will become chloroethane. Is that okay? and this become hydrogen. This hydrogen that has been displaced will come and form with this. Let's use another color. This hydrogen that has been displayed will come and bond with this remaining chlorine. They will bond to form hydrogen chloride or hydrochloric. They form this hydrogen chloride. Okay. Why here you have chloroethane? The reaction is exothermic. Now the board energies are shown in this. Okay, we're going to do energy calculation. What's the energy change? Okay, first you calculate energy in, which is energy in breaking the bond. So how many CH? Here you have CH, right? How many CH do we have here? 1, 2, 3, 4, 5, 6. So the CH we have here is 6. So I'll write CH times multiply by 6. CH, I'll take the bond energy, I'll multiply it with 6. So we want to calculate energy in, then we calculate energy out. Energy in is the total energy in the reactant, energy out is the total energy in the product. Okay? Energy in the reactant, energy in the product. So in here we have 6, CH is 6. And then we have C to C, which is a different one, C to C. Don't forget that there is a carbon to carbon bonding here in the middle. Carbon to carbon bonding. So you say plus, that one is only one. C to C. C to C is only once, right? Is it twice? No. If it's twice, you multiply by 2. If it's once, you multiply by 1, or you just leave. You don't need to multiply by any one. Okay, so we're done with C to C. Okay, plus C to chlorine to chlorine. Chlorine to chlorine is there? Do we have? Yes. And it's only once. Plus chlorine to chlorine, which is once. Chlorine Cl to Cl single bond. So this is our total energy in. So I call it E in. These are energy in. Okay? We'll do energy out, and then we will subtract energy in minus energy out. We get the energy change. So energy in is 6 times. C to H is what? What's the energy bond? Go to the diagram. C to H is 410. So you say 6 multiplied by 410. 6 multiplied by 410. Then plus, you can put this one in bracket if you like. Plus, C to C is what? C to C is 350. So we say plus 350. Okay? You know, when you're doing the exam, you're faster. Okay? Because we are explaining it, it's taking a little bit of time. Chlorine to chlorine, 240, you say plus 240. So let's get the total energy in. What value do we get for the total energy in? Quickly. 6 times 4, what value do we get here? Our energy in is equal to what? Our energy in equal to 2,460. So here we have 2,460 plus 350 plus 240. So what's the total? Plus 350 plus 240. You get 3,050, right? You get 3,050. That's your total energy in. So this will give you your total energy in to be 3,050 kilojoule per mole. 3,050. Remember the unit is kilojoule per mole. Okay, you can see the unit here, kilojoule per mole. Okay, so you can say 3,050 kilojoule per mole. So this is the unit for your energy in. Remember, they want us to calculate energy change. Calculate the energy change. Okay, now let's calculate energy out. Before you can do energy change, you have to do energy in and energy out. So what's our energy out? Energy out is the total energy forming new bond. The sum of the energy forming new bond. Let's see the new bond that was formed. We have carbon to chlorine, how many? Carbon to hydrogen, how many? 1, 2, carbon to hydrogen, 2, 3, 4, 5. Okay, 5, right? So we have C, carbon to hydrogen is 5. So we multiply it by 5. In this case, it's 5. Okay, it's not 6 because one hydrogen has been replaced with chlorine. So it's 5. So here I put times 5. Plus. Now we have carbon to carbon only once, right? Carbon to carbon bond. So we say carbon to carbon bond. Then plus, that one is only once. Plus carbon to chlorine bond. 1 is also once. Carbon to chlorine bond. So we have plus carbon to chlorine bond. I think that's all for this one, right? So we add. Let's add. Then before we now add the next one, which is hydrogen to chlorine. Okay? Plus the last one, hydrogen to chlorine bond. Plus the last one, hydrogen to chlorine bond. Okay, let's add them. 5 times carbon to hydrogen is what? Carbon to hydrogen is 410. So 5 times 410. 5 times 410. Okay, you can close. You say plus. Carbon to carbon is what? 350. Plus 350. Plus 350. Then plus carbon to chlorine is what? Carbon to chlorine is 340. Plus 340. Plus 340. Then hydrogen to chlorine is what? Hydrogen to chlorine is 430. Plus 430. Plus 430. Plus 430. So now let's find the total energy out. Okay? Let's find total energy out. This is not difficult, it's very easy. Just you should know the techniques. Now let's find the total energy out. So 5 times 410 gives us what? 5 times 410 gives us 2050. 2050. Okay, we get 2050 plus 350 plus 340 plus 350 plus 340 plus 430 plus 350 plus 340 plus 340 plus 430, and let's see what we get as our energy out. What do we get? We get 3,170. We get 3,000. The total energy out. Because it's exothermic reaction, Enzo, you're going to get a negative answer. Okay? Enzo is negative. It means it gives out heat. Okay? So we get 3,170. Okay? Now, energy change. Remember, energy change, you put delta E, energy change, or change in energy. Energy change is equal to your energy in minus energy out. Your energy in means energy in breaking the old bond, minus energy out. Energy out means energy in forming new bond. You know you have to break the old bond. You have to break the old bond in order to form new bond. You have to break this old bond. You have to break it in order to form new bond. So the energy that is used to break the old bond is called energy in. The energy that is used to form these new bonds is called energy out. So the answer you get in your energy in breaking the old bond is 3,050. So 3,050 minus the energy out, which is 3,170. 3,050 minus 3,170. So we're going to get a negative number in kilojoule per mole. So this gives us what? A negative number in kilojoule per mole. which is negative 120, which is negative 120 kilojoule per mole. So if you check your answer, you should look for any option that has negative 120. Why you know you're correct? Because exothermic, they mentioned that at the beginning. They say it's an exothermic reaction. See, they mention it here, exo. So meaning you should get negative answer. It's an exothermic reaction, and so the answer is B. The answer is B. Negative 120, not negative this. So this and this already out. See, in the exam you should know questions that are outrightly out. It's not endo. Endo is positive. They say exothermic. So the answer lies between A and B. So after solving, you able to know that it's the answer is B, right? Okay, that's question number 11, right? Okay. Now let's go to question number 12. Question number 12 is a chlorine gas is bubbled into aqueous potassium iodide. Chlorine bubbled through potassium iodide. Now, what is the ionic equation for the reaction that takes place? What is the ionic equation for the reaction that takes place? Chlorine gas is bubbled through potassium. You know, it is the halogen that will give way in the half equation. You say chlorine gas is bubbled into potassium iodide. So if potassium is K, you can write you can break it down, the half equation. Iodine is minus. Iodine will be minus, but multiply by 2 here because there are two of it. So you can summarize this one. Plus, there's a plus here, okay? Maybe we choose a different color this time around. You close this bracket. Okay. Plus chlorine. This will give us an iodine. Chlorine will display iodine. So what will we have? We will have chlorine gas react with 2 ions in the half equation. Two molecules of 2 ions of iodine to produce, chlorine is higher than iodine in reactivity series. So to produce chloride ion, when you bubble it through, it will chase iodine. You now have potassium chloride instead of potassium iodide. See, like this. Potassium. If you write the equation like this, potassium iodide plus chlorine gas, the normal equation, we produce potassium chloride plus iodine. To chase iodine out. So you can put 2 here. And put 2 here. And put 2 here. Okay, so in that case, you produce potassium chloride. In half equation, you are not writing the potassium. You are just showing the one that is displaying which one. So you write potassium. Since is now potassium chloride instead of potassium iodide. When we have potassium iodide, we roll only the iodine. We don't write the potassium. Now, if you form potassium chloride, you write only the chloride ion. So, but you can balance it by putting the 2. There's 2 at the back of it. Put the 2 here, plus the iodine. Iodine will not be on its own. Instead, the way you had chlorine on its own that you bubble through, you now have iodine on its own. So this will be the half equation. This one will be the ionic half equation for this reaction. So which turns down to A, B, is wrong because of this. You don't have ion, you have atom and ion together. So B is wrong. A is not even balanced. You don't have chlorine like this, doesn't exist like this. Chlorine is the atomic. So C, yeah, chlorine gas, bubble through potassium iodide to produce potassium chloride plus iodide. C is correct. Okay, and D, let's see this one. Produce this plus, no, not two molecule. D is wrong. So C is the most correct answer. Okay, for this reaction. We'll go to question 13. And let's see question 13, what we have for question 13. Question 13 says concentrated sodium, aqueous sodium chloride, concentrated aqueous. It's concentrated as aqueous, so there's water in it, but it's concentrated aqueous sodium chloride is electrolyzed. Which equation represents the reaction at the cathode? Cathode is the negative electron, so it's the positive ion that will take place. Of course, this one is very famous. You should know this one, hydrogen. Why? Because sodium, the positive ion that you have in the electrolyte is sodium ion and hydrogen ion. Because you dissolve it in water. Because you say concentrated and you say it's aqueous. So since you dissolve it in water, you also have hydrogen ion. Hydrogen is less than sodium in reactivity series. So it is the lesser one that will move, that will migrate, that will be discharged at the cathode. So this hydrogen will be discharged at the cathode. Okay, this hydrogen will accept 2 electrons. This hydrogen will accept 2 electrons. Okay, 2 electrons that is coming from the battery. We accept 2 electrons to produce hydrogen gas. To produce what? Hydrogen gas. This is reaction at the cathode. So if you study electrolysis, you know this one very quickly. That sodium will not go. Sodium will stay behind. Okay, sodium will stay behind and probably react with hydroxide, OH ion, the negative ion, to produce sodium hydroxide, to produce sodium hydroxide alkaline. So this is what is the OH ion will react with it. We react with the remaining sodium that didn't go to produce sodium hydroxide. But the hydrogen, which is less than sodium, the positive ion, you have 2 positive ion, 2 negative ion. Okay, the second negative ion is the chloride ion, the chlorine ion. Okay, but they are not asking us what is happening at the anode, so we are not going to bother ourselves. We'll only bother ourselves with what's happening at the cathode. So this hydrogen ion will be discharged at the cathode. We migrate to the negative electrode. We migrate to the negative electrode, which is cathode, and accept 2 electrons to become hydrogen gas. So the correct answer is C. Correct answer is C in this regard. Let's go to question 14, right? Let's go to question 14. Question 14 is which statement about hydrogen are correct? Which one is correct for hydrogen? Hydrogen, when hydrogen is born, heat energy is released. Yes, right? Because it's used as fuel. Hydrogen can be used as fuel. You remember that. Okay, heat will be released. When hydrogen is used in fuel cells, you see it can be used as fuel. Used in fuel cells, electrical energy is generated. Yes, that's true. When you use it in fuel cells, it can generate electrical energy. And when hydrogen is used as fuel, water is the only product. Yes, water is produced. It reacts with hydrogen. When it's used as fuel, hydrogen reacts with oxygen to produce water. Water is the only product that is produced. Produce water. So to produce water, 2H2O to produce water. Okay, but that's not the big one. So it means the 3 are correct. So we look for the option that has all 3. A. So A is our answer for this question. Go to question 15. Solid X is heated strongly. The color of the solid changes from blue to white. What is solid X? The color changes from blue to white. When color changes from blue to white, what is that? This is the test for color with the qualitative analysis in chemistry. You need to know this for paper 6. Okay, you need to know this one for paper 6. right? For paper 6. Now, when color changes from blue to white, what it means is that copper is involved. Copper. Okay, copper changes from blue to white when it's heated. Copper is blue color. When you heat it, you get a white precipitate. You get white precipitate. So aqueous cobalt 2 chloride, no. Calcium carbonate, no. Hydrated copper 2 sulfate, yes. Hydrated copper 2 sulfate. Copper 2 sulfate. Dot. I think for copper is 5. Dot 5 H2 H2O. Okay, this is hydrated copper 2 sulfate. So it will, when you heat it, this water will evaporate and it will make copper 2 sulfate only. So the color will change from blue to white. Is that okay? Question number 15. Yeah, the color will change from blue to white. Right? So we move to the next question. Question number 16. What's our 16? Question 16 says iron 2 chloride solution react with chloric gas. Iron 2 chloride solution react with chloric gas. So this can only form iron 3 chloride, right? Because more chlorine will join here. So which statement about the reactions are correct? Which statements about the reactions say iron 2 ions are reduced to iron 3 ions? Is that so? No. If you have said oxidized to iron 3 ion, we would have said yes. Chlorine acts as a reducing agent. Is chlorine a reducing agent or oxidizing agent? It's an oxidizing agent. Okay? Right? Then iron 2 ion each lose an electron. Yeah. To become iron 3, right? So this one is correct. They lose electron. Oxidation is the loss of electron, right? Or a ring. Oxidation is the loss because it's about oxidation. Chlorine molecules are reduced. So chlorine ion. Yes, that's true. Chlorine molecules, this whole chlorine molecule, this is a molecule. It's now reduced to chlorine ion. It's not an ion because it's forming a compound. So it's an ion. So I think the two correct options are 3 and 4. Chlorine molecules are reduced to chlorine ions. And 2, they lose electrons. So the right answer is D. Question number 60 is D. We go to question number 17. Question number 17. Which statement about acid and base are correct? About acid and base are correct. You know, acid are protodonor and base are protoacceptor. Okay? Acid, so let's say an acid react with a metal to give off hydrogen. Yes, that's true, right? When acid react with metal, when acid react with hydrochloric acid, now you can write equation. Hydrochloric acid react with sodium. Hydrochloric acid react with sodium. You can just be using equation to test it. To test any statement they make. To become what? Sodium chloride plus hydrogen gas. Sodium chloride form a salt and hydrogen gas. Okay, plus hydrogen gas. You can balance your equation. Can balance. Okay, you can put 2 here, and put 2 here, and put 2 here. Okay, to balance your equation. So this is true. Acid react with metal to give off hydrogen, to give us hydrogen. Number 1. Number 2, a base react with ammonium salt to give ammonia. A base react with ammonium salt to give ammonia. That's true, right? Kind of true. Then, number 3, an acid react with carbonate to give up carbon dioxide. That's true. When they react with carbonate, they produce carbon dioxide, they produce water, and they produce salt. Okay. Alkali solutions are orange in methane orange. No, they're not orange. Alkali solutions are not orange. So 1, 2, 3 are correct. So our answer will fall in A, right? Let's move fast. Our answer will be A. I hope we are correct. Yeah, our answer should be A because should be A. Now let's go to question 18. Question 18 says, oxide 1 is a solid that reacts with dilute hydrochloric acid. Oxide 1 is a solid that reacts with dilute hydrochloric acid. Oxide 2 is a gas that reacts with sodium hydroxide solution. Now, what are the formula of oxides? What are the formula of this oxide? Oxide 1 is a solid that reacts with dilute hydrochloric acid. Yes, like this one. Like calcium. Calcium oxide, magnesium oxide can, right? And let's see the second one. Oxide 2 is a gas. This is not a gas. This is not a gas. Magnesium oxide is not a gas. But so nitrogen dioxide is a gas. Nitrogen dioxide is a gas. Okay, because it says oxide 2 is a gas. So this is where the answer, this is what brought the determinant of the answer. So our answer is B. Okay. The answer is supposed to be between A and B. Oxide 1 is a solid. These two are not solid. C and D, you can see they are gases, they are not solid. So C and D are wrong because they are not solid. So C and D are wrong. The correct answer is B. Correct answer is B. Now we go to question 19. Which reaction is a photochemical reaction? 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 Okay, maybe we split this video into two, part 1 and part 2. We finish, we continue immediately. Which reaction is a photo means the one that gives light. Okay, which reaction is a photochemical? When you say photochemical reaction, you're talking about reactions that involve light. Okay, addition of bromine to propane. Addition of bromine to propene, no. Acidification of ethanol and ethanolic acid, no. Does it require light? Oxidation of ethanol. Substitution of methane with chlorine. Yeah. This one you see requires what? All the substitution reaction. When you take methane, they require what? Sunlight. They require a UV light. You can go and check your organic chemistry plus chlorine. You get the first one, you get chloromethane. You get CH3Cl. One hydrogen has been removed from here. One chlorine will replace it, CH3Cl. This is what you get now. This is called chloromethane. Plus one hydrogen that has been removed from here plus the remaining chlorine atom will form hydrogen chloride. This reaction requires the presence of a UV light. You need a UV light for this reaction to take place. Sunlight, heavy sunlight. If not, this reaction cannot catalyze, cannot happen. So the most correct answer is D. Remember this. Go revise your notes. Okay? Now we go to question 20. Question 20 is the equation shown represent a reaction at equilibrium. This equation that we've shown you, it means a reaction at equilibrium. Equilibrium reactions means that the rate of forward and backward reaction are constant. So M and N represent the balancing numbers for the reactants and products respectively. This is the balancing number for reactor, this is the balancing number for the product. Now, a high temperature increases the concentration of Q. High temperature increases the concentration of Q. So if you increase temperature, the concentration of Q will increase. A high pressure increases the concentration of Q. Also, a high pressure also increases the concentration of Q. Now, which statement about the reaction is correct? Which statement about the reaction is correct? The forward reaction is exothermic and M is greater than N. No. The forward reaction is exothermic, and M is less than N. The forward reaction is endo. The forward is endo. The forward reaction is endothermic, and M is greater than N. Yeah, the forward reaction is endothermic. It's not exothermic. Okay, because of the condition of pressure and concentration they mentioned. If it's temperature, forward reaction would that be exothermic. So the forward reaction is endothermic, and M definitely is greater than N, because you are like you are breaking the composition reaction like carbonate, like calcium carbonate. When you're breaking calcium carbonate, you produce lime. Okay, you produce calcium oxide, which is lime plus carbon dioxide. Okay, this is the type of reaction they are mentioning. Okay, so at equilibrium, let's say forward reaction. So we say the forward reaction is endo, and this one, the coefficient of this one must be greater than the coefficient of this one. So C is the most correct answer. Okay. Okay, we'll go to question 21. Question 21, a period of the periodic table is shown. Look at the period of a periodic table. Now the letters are not their chemical symbols. The letters that will be given are not their chemical symbols. You can see, these are not symbols, they just use letters. Now which statement is correct? Which statement is correct? Element R does not conduct electricity. Element R is group 1. Group 1 do conduct electricity, so it's not correct. Right? The B, element R and Y react together to form ionic compound. Yeah, like sodium, for example, is in group 1. So you can check whether that statement is correct. And Y. Y is group 7, like chlorine. It's in group chlorine. So sodium plus chlorine will form ionic compound, right? This will form ionic compound. You just use your logic. This is group 7, so you can take any example. This is group 1, sodium. You can take any example. Lithium, sodium, potassium. They are in group 1. So I take sodium, react with chlorine, I get sodium chloride, which is an ionic compound. So that means this option is correct. They react together to form ionic compound. So this is correct. But we can check others to see. Element Z exists as the atomic molecule. Element Z. Group 8, is it the atomic? Okay, no. It's not the atomic molecule. Okay? It's not the atomic molecule. Element Z reacts with element Z does not react because it's balanced already. The outermost electron is 8 already. So it does not react. So this is not correct. This is not correct. So the correct answer is B. We go to question 22. I think we should increase our speed if we have to finish faster. 22A says all metal nitrates are soluble in water. All metal nitrates are soluble in water. All metal carbonates are soluble in water except silver and lead. All metal carbonates are insoluble except they are insoluble in water. All metal carbonates are insoluble. But nitrates are all soluble. All metal nitrates like potassium nitrate, calcium nitrate, sodium nitrate, they are all soluble in water. Meaning they dissolve in water. All metal chloride, they are all soluble in water except silver chloride and lead chloride. All metal carbonate, they are insoluble, they are not soluble. They do not dissolve in water except sodium and potassium carbonate. Potassium carbonate is soluble in water, sodium carbonate is soluble in water. Which aqueous solution produce a precipitate when mixed together? Which one will produce a precipitate when you mix them together? Silver nitrate plus sodium carbonate. You know sodium carbonate is soluble, right? Because except sodium, right? Sodium and potassium. So sodium carbonate is soluble, right? And when it reacts with silver nitrate, they will produce soluble solution, right? Which aqueous solution produce a precipitate when mixed together? This one will produce a precipitate. Silver nitrate and sodium chloride, they will produce a precipitate. This one and 2 will produce a precipitate. Barium nitrate and barium chloride, no. Barium nitrate and barium chloride, no. Not produce a precipitate. So I think we go with option 1 and 2. Now question 23. Question 23, which role describe properties of transition metals? You know transition metals, they form color compounds. Number 1, they form color compounds. they form variable oxidation state. They have a variable oxidation state. You have to know these three things. They form color compounds, they form variable oxidation state, and the third one, they have not just high density or so, we know they do. Okay, we know they do. Okay, we can choose high density, form color compound. So let's go through this option. Which of this option is better? Question 23. We say they form color compound. You can see color compound. Property 1. They have high density. They have variable oxidation state. And they have high density multiple is for other methods. Even high melting point is common with even other methods that are not transition methods. One oxidation state, no, they form variable oxidation state. Anything that shows one oxidation state is wrong. So B and C are wrong. We can look at this, low melting point. They don't have low melting point. So D is also wrong. So the most correct answer is A. So we go. Question 24. We go to 24. Now the noble gases are in group 8 of the periodic table. Which statement explains why noble gases are all reactive? Why are they all reactive? They all have 8 electrons in the outermost shell, right? Yeah? They already have 8 electrons in the outermost shell. That could be. Is that the reason? They all have full outer shell. This one is stronger. You see why we have to read all? See, they all have full outer shell. All full. Right? They are all gases, not really. They are so the answer is B. They have full outer shell. They have full outer shell. The answer is B. We go to 25. It's more superior than A. They all have 8 electrons in their outer shell. Do you know why this is not the correct answer? You know helium. Helium is also a noble gas. Does it? The atomic number is 2. The only shell is 2 electrons. And is the only shell and is the outer shell. Is the only shell and is the outer shell. This question is very logical. Okay, is the only shell and is the outer shell. So it does not have 8. All the rest they have 8 except helium. All the rest they have 8 electrons. So it's better to go for a superior argument. They all have full outer shell. Just say full outer shell is a better answer than saying that they all have 8 electrons. They actually have 8 electrons except helium. Helium does not have 8. The next one is neon for noble gas. You know, atomic number is 10 and the first shell is 2. This outer shell is 8. So others have 8 in their outer shell. The next one is argon. It has 8 in the outer shell. But the first one does not have 8. That's why many students will go for A. Many students will go for A. But there's a stronger answer than A. They don't all have 8. So always go for full outer shell electrons. Go for full outer shell electrons. So we go to question 25. Question 25. Okay? Which statement is correct for all metals? Which statement is correct for all metals? All metals, they conduct electricity when they are molten. That's correct. Let's see if there is a stronger argument. They gain electrons. No, they don't gain electrons. They lose electrons. So metals lose electrons. They have low density. No, they have high density. Metals don't have low density. They have low metal. No, metals don't have low metal point. They all have high metal point. So the stronger answer is A. They all conduct electricity when they are molten state. When they are in molten state. We go to question 26. Carbon dioxide is produced during the extractions of aluminium from bauxite. Carbon dioxide is also produced during the extraction of aluminium from bauxite. You know, aluminium is extracted from bauxite. Okay, which statement describe how the carbon dioxide is produced? Okay, which statement describe how the carbon dioxide is produced? So carbon monoxide reduces aluminium oxide, forming carbon dioxide and aluminium. No. Carbon dioxide is burned in the blast furnace to release heat energy. Oxygen made in the process react with the carbon electrode to form carbon dioxide. Yes, C. The oxygen that is made in the process react with the carbon electrode. You know the electrodes? You have carbon electrode. They react with the carbon electron to form carbon dioxide. So this one is a better answer, to form carbon dioxide, okay? To form CO2. So this is a better answer. We go to the next one, 27. Aluminium objects do not need protection from corrosion. Why is that? Aluminium objects do not need protection from corrosion. Okay? Iron object must be protected from corrosion. Yes, iron must be protected from corrosion. Which statements explain why aluminium resists corrosion? Aluminium does not form iron easily. Could that be the answer? No. Aluminium does not react with water or air. Could that be the answer? Aluminium has a protective oxide layer. Yes, because naturally aluminium has a protective oxide layer. Please take note. When they ask you in the exam, why does it not need protection from corrosion? You say because it already have a protective oxide layer. We go to 28. Question 28. Which statement explains why zinc is used to protect iron from rusting? Why zinc is used to protect iron from rusting? Zinc is more reactive than iron. That's correct. Zinc is more reactive than iron, so you need it. Zinc is less reactive. No, it's not less reactive than iron. Zinc can form alloy with iron. No, not really. Zinc acts as a sacrificial metal. Could be, right? Zinc can form alloy with iron. Yeah, can form alloy, right? Wait, I think we have to take this question again. Okay, zinc cannot form alloy with iron. And zinc acts as a sacrificial metal. Yes, partially, because there's no option with only one. So A is wrong. 1 and 4 is most likely to be correct. 2 and 3 no. 2 and 3 are definitely wrong. 2 and 4 no. Zinc is not less reactive. You can check your periodic table or reactivity series. Okay, so the correct answer is B. We go to question 29. Question 29. Which conditions are used in the Haber process? Oh, we talked about this every time. Haber process. The temperature is always 450, right? And the pressure is 200 atmosphere. Please take note. Okay, this comes out almost every year. So always take note. Is that okay? Which statement, question number 30, which process does not produce a greenhouse gas? We studied the greenhouse gas. Okay? Acid rain on limestone building. Yes, you produce a greenhouse gas. If you have acid rain on limestone building, you produce a greenhouse gas. Combustion of wood, you produce greenhouse gas. Or when you burn wood, we release sulfur dioxide or carbon dioxide. So you produce a greenhouse gas. Digestion in cow, you produce greenhouse gas. Okay? Because it releases some of the greenhouse gas to the atmosphere. Reduce carbon dioxide to the atmosphere. Zinc reacting with sulfuric acid does not produce greenhouse gas. When zinc reacts with sulfuric acid, produce zinc sulfate and hydrogen. So there's no greenhouse gas produced in this process. So our answer is D for this question. Question 31. Which reaction involving sulfur dioxide is correct? Which reaction involving sulfur dioxide? It is produced during the extraction of zinc from zinc blende. Yes. Sulfur dioxide is produced when you are extracting zinc from zinc blende. Okay? You know zinc blende is zinc sulfate. This zinc sulfate, this is called a zinc blende. Okay? When you are producing zinc from here, reaction involving sulfur dioxide is correct. It is produced, this sulfur dioxide is produced because you burn it in oxygen. You burn it in oxygen, you will now produce sulfur dioxide. You produce sulfur dioxide. Remember that. You produce zinc. You can balance the equation if you do so wish. You produce zinc and sulfur dioxide. So they say which reaction is this? So I think A is correct. A is correct. Is that okay? Now we go to question 32. A is very correct, so we don't need to waste time. Lime, which is calcium oxide. Lime is obtained from limestone when you blast calcium carbonate, which is limestone. Lime, calcium oxide, CaO, is used to treat wastewater from a factory. Now, which substance is removed by the lime? Which substance will the lime remove, right? Which substance? Is it ammonia? No. No. Is it sodium chloride? No. Is it sodium hydroxide? No. Sulfuric acid? Yes. So lime will remove sulfuric acid from the waste water from the factory. Is that okay? You react with it and produce something else. Now we go to question 33. Question 33. Now, what is the structure of ester formed from ethanoic acid and propanol? The ester formed from you have to get a propene-ethanoate. Propene, if you react propanol with ethanoic acid, you have to get a propene-ethanoate. So propene-ethanoate will be 1, 2, 3. This propyl ethanoate, this ethanoate. It's ether because it has 2C. Ethanoate, double bond to O, single bond to O. So this, I think this is the most correct one. Let's see this one. This is not propyl ethanoate because there's another oxygen here. This is a propanol ethanoate. There's nothing like propanol ethanoate. This is also a propanol. This is a propanol propanoate. So this is wrong. This is ethene propanoate. This is wrong. So the correct answer is D. You produce a propyl ethanoate. You produce a propyl ethanoate. Okay? If I want to do the structure, it will waste our time. So I hope you understand. Okay? Now question 34. Question 34. We say fuel X produces carbon dioxide and water when it is burned in air. When it is burned in air. So does fuel Y. So we have X and Y. They will produce what? Carbon dioxide, CO2, when it's burned in CO2 and water when it's burned in air. So what is the? Definitely it's not carbon. Carbon cannot produce water and carbon dioxide. Because see, if you react carbon with O2, air means in this case we are referring to oxygen. You only get probably CO2. You cannot get water. So it is when you use methane, which is a gas, and methane and octane. This octane. Okay? So the correct answer to save time is this. You must use two gases. Not in this other option they're using one. This is a gas, but it's not a methane gas. Okay, it's not a hydrocarbon gas. It's just hydrogen gas. So it's not correct. So correct answer is D. We go to question 35. Question 35 says the structure of 4 organic molecules are shown. We have, instead of methane, we have chloromethane. We have methanoic acid. This is a methanoic acid. C, double bond to O, single bond to OH. And then we have H. This is a methanoic acid. This is ethanoic acid. Ethanol. This is an ethanol. This is not an acid because it doesn't have 2 O. To be an acid, you have double bond to O, single bond to OH. Okay, this ethanol, and this is methanol. This is a methanol. Okay, how many different homologous series are represented by these molecules? This is ethanol, methanol. So it's O. This O. Like alcohol group. This alcohol. This also alcohol. So I put OL. This is also alcohol. This acid, carboxylic acid. This is an acid. So we've seen 2, 1. These are same as 1 because they are both alcohol. It's considered as one carboxylic, one homologous series. 2, and then this is chloromethane. This third one. Okay, I think we have 3, right? 35. We have 3. So the answer is C. Because this is a methane, this is a different homologous series. So we have 3. These considered as one homologous series because they are both alcohol. Whether you are in methanol or ethanol, is both same homologous series. Okay? And why this is a methane family or alkane family? You can say alkane family. Okay, this is alkane homologous series. You have the alkane, which chloroethane. You have the alkane family. You have the acid, carboxylic acid, and you have the. So let's go to the next question. Question 36. Which statement about ethene is correct? Which statement about ethene is correct? Let's be fast, quick about this. Which statement about ethene is correct? Question 36, right? You say it has a chemical formula ethene. Which statement about ethene? No, ethene is C2H4, right? C2H4. C2H4. So it's not C2H6. This ethane. So you say it has a chemical. The A is wrong. A is wrong. B, it bonds in excess oxygen, produces carbon dioxide and water, right? It bonds in excess oxygen, producing carbon dioxide and water. Is that true? Yes, I think it's true. But let's check the others. It reacts with bromine, produce an orange solution. No. It reacts with oxygen to form ethanol. Not really. Not really. Okay, so the most correct answer is B. Now we go to question 37. Now let's take a look at 37. Ethanol is manufactured by fermentation of sugar or by ketonic hydration of ethene. So if you go and brush your notes. If you're in this IGCSE level, you should have done these 2 methods of producing ethanol. Ethanol is manufactured either by fermentation of sugar, which is biological process, or by catalytic hydration of ethane, which is a chemical process. Okay, so fermentation is a slow process. This is a fast process. Now let's see. Is which role states an advantage of each method? Advantage of fermentation is that I produce pure ethanol, no. Produce pure ethanol, no. Use renewable, yes. This one use renewable because sugar is a renewable resource. Okay, use a renewable resource. So the answer is between C and D. And then hydration is a batch process, a continuous process. Hydration is a continuous process, right? Hydration is a continuous process, it's not a batch process. So the most correct answer is D. The most correct answer is D. Okay, we go to 38. Which statement about unsaturated hydrocarbons are correct? Unsaturated hydrocarbon. Unsaturated, you know the saturated one? Alkanes are saturated. Alkenes and alkalines are unsaturated. They contain both single and double bonds. That's not entirely correct, right? Question 38. That's not entirely correct. Is it correct? They contain both single. Okay, they are asking which statement about unsaturated hydrocarbons are correct. They contain both single and double bonds. Okay, let's move on. They turn aqueous bromine from colorless to brown. Aqueous bromine, no. They can be manufactured by cracking. Yeah. Unsaturated hydrocarbons are manufactured by cracking process. You know unsaturated? You know unsaturated? Like the alkenes, all the alkenes, ethane. Yeah, they contain both single and double bond. For example, propane. See? Propene. Double bond to the first one, then single bond to this other one. Propene 1, prop 1E. Prop 1E. They contain both double bond and single bond. So 1 is correct. They contain double bond and single bond, and they are manufactured by cracking. So 1 and 3 are the most correct one. So our answer will be B. 1 and 3. Our answer will be B. Is that okay? Let's go to 39. 39. Which polymer have the same link between monomer units? Let's take it again. What are they saying? Which polymers have the same linkage between monomer units. Carbohydrates are polyamide? No. Carbohydrates are polyester? No. Protein and polyamide? Yes. Protein and polyamide. They have the same link. Okay? Between both the polymer and the monomer, they have the same linkage. So C is the most correct one. Then the 14, the last but not the least. So the diagram shows the partial structure of pterylene. Okay, you can look how it's formed. Double bond to O, single bond to O, then the shaded one to O again. Okay, it says from which pair of compound is it made? Obviously from the compound that has this. On this other side you have C, double bond to O, single bond to OH. So from this one, it's made from one of these, because if you want to extend it, this, you have on this other side you have C, double bond to O, single bond to OH. Single bond to OH. The OH on this side you write like this. To look like HO, but it's OH actually. Okay? But you are ready to the left. To the right, here is supposed to be H. You understand? The monomer that made it. So meaning it's a carboxylic acid, and the other one is what? This other one, O to O. O to O will be, in this case, hydrogen is removed, right? All the hydrogen atoms are removed in the embedded structure. Okay, so this one will be the shaded. You just put hydrogen here. So these are the monomers. I think this one is pretty easy. Okay, these are the monomers that formed it. You can see this is completely wrong, because there's no C. See, this one is from this shaded one to O straight. This shaded one to O straight. So there's nothing like this, nothing like this, nothing like this. So the answer is it. So with this, we've come to the end of our today's class. Thank you for joining us.